In this lesson, we're going to look at functions and relations. A relation is a correspondence between two sets, usually referred to as the domain and range. Essentially, everything in mathematics is a relation. This first image here shows us an example of a relation. If we look at the ordered pairs that are associated with this, we got the point -9, 1, -5, 5, 1, 8, 7, 1, and 7, 4. So this is the correspondence between the two sets represented with the points. For a relation to be a function, each element in the domain is paired with exactly one element in the range. So from the mapping, we can see this by the arrows, each arrow coming from the numbers. There's only one arrow coming out of that number. Up here, there were two arrows coming out of the 7. So not a function. Down here, each of the numbers has only one arrow coming out of it. Looking at these ordered pairs, you can see that 1, 3, 5, 9, your x coordinates have no repetition in them, which is another way that you can tell that you have a function. There is no repetition in the x's. Each x is paired with exactly one y. In order for something to be a one-to-one function, then each element in the range must also be paired with each element in the domain. So it has to pass the function test and then also the additional concept of each element from the range paired to exactly one element from the range. So if we look at the ordered pairs here, we have 4, 5, -2, 1, 5, 6, 0, 2. No repetition in our x coordinates or in our y coordinates. So that's an example of a one-to-one function. We're going to look at a couple of different representations of equations, relations, and functions and be able to tell when we have a function and a one-to-one function. So first we're going to look at graphs. Every graph is a relation. If a graph passes the vertical line test, then the graph represents a function. You should remember the vertical line test from Algebra 2. And if the graph passes a horizontal line test, then the graph represents a one-to-one function. The horizontal line test is simply the same thing as the vertical line test, except using a horizontal line. So this graph that we have over here is a relation because every graph is a relation. If we pass the vertical line through this graph, we can see that there is no place where the vertical line intersects the graph in more than one spot. So it passes the vertical line test and would therefore be a function. If we do the horizontal line test and pass this horizontal line over the graph, we can see that at multiple points, the horizontal line intersects the graph in multiple points, and therefore this fails the horizontal line test and therefore is not one-to-one. So passes the vertical line test, therefore the graph represents a function, fails the horizontal line test, therefore it does not represent a one-to-one function. Looking at some additional examples here. This first graph, if we use the vertical line test, so we're going to look at this, and we can see that it intersects in more than one spot. Therefore, we know that it is not a function. Always do the vertical line test first, because if it is not a function, you do not need to test whether or not it is a one-to-one function. So this is not a function because it fails the vertical line test. Continuing over to the second one, initially we're passing the vertical line test, but then we can see here we're intersecting in multiple points, and therefore we are failing the vertical line test, and we therefore do not have a function. Continuing over, if we pass the vertical line through this graph, we can see that it passes the vertical line test. So it is a function. So then we're going to try the horizontal line test. So as we can see here, we're going to fail the horizontal line test. So therefore it is not a one-to-one function, and you can see that it fails it in multiple spots. So passes the vertical line test, therefore a function, but fails the horizontal line test, so it is not a one-to-one function. Moving down to the ones in the second row here, this graph passing through this passes the vertical line test, therefore it's a function. So then we can continue and try the horizontal line test, and we can see that this passes also a horizontal line test. Therefore, this graph is both a function and a one-to-one function. So we should not have the word not here. That is a one-to-one function. Moving on to the next graph here. We pass the vertical line test. We also pass the horizontal line test. Therefore, we again have a one-to-one function, and we're going to remove that word not there. It is a one-to-one function. And finally, on the last one, we will take the vertical line and pass this through the graph. It passes the vertical line test. It does not pass a horizontal line test. So therefore, this passes the vertical line test and is a function, but it fails the horizontal line test, so it is not a one-to-one function. Moving on from graphs, we're going to look at mappings, or essentially tables. Every mapping is a relation. If there is no repeated values in the x values, then it is function. If there's no repeated values in the y values, then it is a one-to-one function. Again, always test the x values first, so test to see if it is a function, and then the y values. So from this table here, you can see repetition in the x coordinates. So therefore, we know that this graph is not a function, and therefore cannot be a one-to-one function. Moving on and looking at some additional examples here. This first table, 1, 2, 3, we see repetition in the x coordinates. Therefore, this is not a function. Looking at the next table, 1, 2, 3, 4, 5, no repetition in the x coordinates, so it is a function. All of our y values are 3, so obviously repetition in the y values, so it is not a one-to-one function. So function, but not one-to-one. In the next table, we have 1, 2, 3, 4, 5 in our x values, so no repetition. We do have repetition right here in the y values, so again, this would be a function, but not a one-to-one function. In the next table, we have 1, 2, 3, 4, 5 in our x's and 1, 2, 3, 4, 5 in our y's, so there's no repetition in x or y, and therefore we have a one-to-one function. The next picture is a mapping instead of a table, but essentially is the same thing. Remember here we're looking at the arrows, so in the x coordinates, each value just has one arrow coming out from it, therefore it's a function. Over here, we have repetition on this y sub 3 value, so there is repetition in the y values. So this would be considered a function, but not a one-to-one function. And finally, in the last table, we have some repetition in those x coordinates. So this one is going to be not a function. Moving on, our last representation that we're going to look at is equations. Every equation is a relation. If that equation in y equals form or function notation, when we refer to function notation, what we're talking about is when we use the f of x or g of x or h of x. Really any letter can be used. If your equation in y equals or f of x form is a unique equation, then that represents a function. What we mean when we talk about a unique equation is that if we have an equation similar to this, where we have y equals x plus or minus 2, that would not be considered a unique equation, because here we have y could be x plus 2 or y could be x minus 2. Plugging in x equals 1, we would get two different values. So we get y equals 1 plus 2, which gives us 3, or 1 minus 2, which gives us negative 1, essentially giving us an ordered pair of 1, 3, or 1, negative 1, giving us repetition in our x values. Therefore, it would not be a function. Essentially, what we're looking for is this plus minus sign together. Anytime we have an equation that has the plus and minus sign in it, or if we have to put that plus and minus sign in when we solve to get y by itself, then we would not have a unique equation. So this would be not unique, and therefore would not be a function. So again, looking at some examples here, we have y equals, so our goal is always to make sure that y is by itself first. In this case, it is y equals x squared minus 9, so y is by itself. There's no plus and minus sign there, so we're going to say that that is a function. Moving across to the right, again, y is by itself. We have it in y equals form. This has that plus minus sign in it, so because of that, this is not a function. So the plus minus sign together is what is telling us that that is not a function. As we move down, the next one, we have y squared, so y is not by itself. In order to get y by itself here, we have to the square root of both sides. And from algebra, you should remember that this means y equals plus or minus the square root of x minus 4. So by putting that plus minus sign in there, we have created a equation that is not unique, and therefore it is not a function. Similarly, over on the next one, we have an absolute value. In order to get rid of absolute value, we're going to do y equals plus or minus the quantity of 5x minus 7. So by putting that plus and minus sign in there, we have created a situation that is not unique and therefore not a function. Moving down to our last two examples, we have this one in y equals form. So y is by itself. Over here, we do not have the plus and minus sign together anywhere, so this would be considered a function. And the last one is in that function notation. So f of x, remember, would be the same as y equals. And over here, we do not have the plus minus sign together. So again, that would be considered a function. Essentially, you can kind of reduce the equations down to as long as your y is by itself and you do not see the plus minus sign, then it's a function. If y is not isolated, if it has an even exponent or an absolute value on the y, then that would not be a function, because those are the cases where when you would solve to get y by itself, you would end up putting the plus and minus sign in there together, creating an equation that is not unique.